Hello everyone, welcome to yourfaculty.com. This chapter is about time and work, and I think it's a fairly simple and straightforward. You'll see some straightforward questions. Uh, Most importantly, you will see questions in data sufficiency with respect to this chapter. All that you need to understand is the basic concept, underlying concept of time and work, and with that, I am sure you'll be able to solve any kind of problem from this chapter. So, this is yourfaculty.com. This is our website www.yourfaculty.com, and that's our Facebook page. Before we start solving our first question, let me try to help you understand the basic concept. Okay, so if we'll take the sample from here itself. If A does a work in 10 days, okay, it takes 10 days to complete a task, right? So how much would he have completed in one day? One day, what is the amount of work that you have completed? It is 1 by 10. That's it. This is enough for you to solve any problem. If you understand that, for any number of people who are mentioned over there, and you know their efficiency, which is 10 days, 15 days, 5 days, or whatever. It could be efficiency, or it could be inefficiency, or it could be leakage, whatever. Leakage of pipes. Okay, so all this. So whatever be it, if you know the total duration, you will be able to arrive at the per unit. It could be per hour. Let's say instead of 10 days, it is written as 10 hours. So we know that in 1 hour, he or she can complete 1 by 10th of the work. This is the basic concept. And to solve the equation, what we need to do, we need to make either the days or the duration part, day or hour, as constant. So once we know it for one day, then we just need to bring the equation out and the answer is right in front of your eyes. Okay, let's try solving for the first question. Okay, A does a work in 10 days and B does the same work in 15 days. We know that for the same amount of work, A does in 10 days and B in 15 days. Now, how many days they together will do the same work together? Okay, so here we need to sum up the effort of A and B. Now, we know that A can do it in 10 days and B can do it in 15 days. So, what amount of work does A do in one day? A's work in one day is equal to 1 by 10. And similarly, B's effort in one day is equal to 1 by 15. So they both are able to complete this much task in one day, right? So if they both work together for a day, how much will they complete? If they both try to work together, A plus B's work for one day. Very simple. You need to just sum up these two values. 1 by 10 plus 1 by 15. And what do you get? You know that it's a common multiple is 30. So you multiply it by 2, you multiply it by 3. 3 plus 2, 5. 5 by 30. And this is equal to 1 by 6. So A and B can complete the work in complete 1 by 6 of the work if they work together in a day. Now it's a vice versa. So A alone can complete 1 by 10th of the work in one day, B 1/15th of the work in one day. If they work together, they complete 1/6 of the work in one day. So how many days will they take? It's a reciprocal, right? You just need to say that they take 6 days to complete the work. Because they complete 1/6 of the work in a day. So it will take 6 days to complete their work, right? So 1 by 6 into 6 is equal to 1, which is the completed work. Total, it's basically 100%, right? So they take 6 days to complete their work. I hope you understood this. That's it. If you understand this, all that they will ask in question is basically they are going to increase the number of entities there, or they might miss out certain values. You just need to apply the same concept across. Now moving on to the next question. A can finish a work in 18 days and B can do the same work in half the time taken by A. So this is the keyword here. Half the time taken by A. Then working together, what part of the same work they can finish in a day? Very simple, right? So how much can A do in one day? Now that you understood the concept, A's one day work is equal to 1 by 18, right? If A can finish in 18 days, B can do the same work in half the time taken by A. How much will B take? 9 days, right? Because it is 18 and B can do same work half the time. So it is 9 days. So B's one day work, 1 by 9. Simple. So A plus B are going to work together and their one day work is equal to 1 by 18 plus 1 by 9. And what do you see? You just need to multiply this by 2 to make it common. 3 by 18 is equal to 1 by 6. That's the answer. Isn't it simple? I'm just now moving on to the next question. A, B and C can complete a piece of work in 24, 6 and 12 days respectively. Working together, they'll complete the same work in. Again, what have they done from with respect to our earlier questions? They have added one more entity, C. Now, what is that? Now that you know, I will try to increase the pace of answering these questions. So what I'll do is, A's one day work, 1 by 24. B's one day work, 1 by 6. C's one day work, 1 by 12. If all of them work together, A plus B plus C, one day work is equal to what? 1 by 24 plus 1 by 6 plus 1 by 12. Right? And what is that? What can be common here? 24 can be common here, right? So this is 1, 6, 4, so 24, 12 2s are 24. So what do you get? You get 7 by 24. So they can complete 7 by 24, 7 by 24 work in a day. So how many days will they take? They will take 24 by 7 days, right? So they take 24 by 7 days. So don't be confused. This can also be written as what? 7 3s are 21. So, and remainder is 3. So don't get confused if the answer instead of 24 by 7, if it is written as 3 by 7. This can also be the answer. Fair enough. Please don't jump into a conclusion that 7 by 24 days are the answer. No, that cannot be the answer. Okay, the basic logic being they take 24, 6 and 12 days to complete the work. 7 by 24 is less than a day. So they cannot complete the work in less than a day, and 1 by 24 is way too less, right, to complete the task. So easily the option could be one of these, and we know that 7 by 24 is the effort that is the amount of work that they can complete in one day together, right? So the reciprocal of that 24 by 7 is the answer. Thanks for watching our video. You can subscribe to more videos at your faculty channel. Like us on our Facebook page and our LinkedIn page, and you can also follow us on Twitter. Thank you.